Okay, can you hear me, guys? Can you hear me just well? Okay, so I guess it's time to start. Sorry for the delay, but I was told that I had to finish. I had to start just on the time and also finish on the time. So, hey guys, my name is Michal Prívozník. I am a senior software engineer here at Red Hat, and for all of the time I've been employed there, I've been working on Libert. And today I'd like to tell you how you can performance tune virtual machines using just like the tool. So firstly, what Libert is? Well, no, firstly, let me start with a question. Who here has ever heard about Libert? Who know? Oh, wow, cool. And who, well, yeah, and who hasn't? One, two, okay. So, majority here, you have to bear with me a couple of slides in the beginning because I had to explain what Libert is for those who doesn't know. So, if you guys have ever played with the virtual machines, like, hypervisors, you probably noticed that each one of them is being controlled completely different. For instance, in QEMU, you have to build this command line where you specify all the devices that you want your domain to have. Whereas in, for instance, VirtualBox, you have to click it in their GUI or just use some API they expose. In Zen, you have to create a config file and stuff like that. So, Libert's aim is basically to hide all these details from you and create a unified configuration and basically management system so that you don't have to bother with all these details and just basically use the virtualization and benefit from it. We are basically implemented in a C, which means we are a C library, we are a standard C library. However, we do expose our APIs in many other languages out there, like Perl, Python, Java, Ruby, whatever you name it. So we are basically not limited to use Libert in your project from this point of view. We do provide a stable API, which means whenever an API has been released, we keep it around for the rest of Libert's lifetime, and we try not to break it. And as a part of that, the configuration itself, configuration format, is considered stable as well. And as I said earlier, we have support for many hypervisors out there, like QEMU, VirtualBox, VMware, Zen in all its flavors, user mode Linux, believe it or not. And also when it comes to playing with the virtual machines, managing them, you want to prepare the host environment some way as well. For instance, you want to pre-create all the network devices, detach all the PCI devices that you are going to pass through to your domain and stuff like that. So Libert has a powerful subsystem for that as well. So how does domain configuration or virtual machine configuration in Libert look like? I maybe spoiled something because domains is how we refer to virtual machines in Libert. Fun fact, who knows why do we call them domains and not virtual machines? Okay, who knows and is not a Libert developer? So it has a historical background. In order to answer that question, I had to rewind clock back to 2005. That's when Libert project was started. And it started as nothing but a Zen wrapper. And even though we gained support for other hypervisors during the time, we basically stuck with the naming that Zen uses. And it's referring to virtual machine as domains. The domain configuration is basically an XML document. Yet again, we had only two options back then when we started the project. It was either XML or JSON. And because the guy who has started the project stands also behind libxml2 and is a part of W3C XML core working group or something, I think the choice we made was pretty obvious. So, in the XML, basically the domain configuration is just putting the correct elements into the correct places or setting the correct values to those elements and attributes. And this XML not only describes the guest part, the guest visible part, but it also describes the host visible part. For instance, here in the emulator tag, I've told Libert which emulator binary should be used when trying to execute my my domain, and also a couple of what should happen when a lifecycle event occurs. Just a second, please. Okay, so the performance tuning with Libert is really just putting the correct values onto correct places within this document. That's it. Libert will basically then take care of the rest, like setting all the knobs in the host system. So yet again, a couple of historical backgrounds. Firstly, the first approach to virtualization has been so-called full virtualization, which is done today as well, but we will get to it. So when it comes to full virtualization, the hypervisor basically does something called binary translation, which means it scans the code that gets wants to run and replace all the non-virtualizable instructions with some trap, which then whenever a guest wants to run such instruction, the trap is hit, the control is handed back to emulator, which will hopefully emulate the instruction and pass the control back to the guest. This is nice. This has one big advantage, meaning that you don't have to modify your guest at all. You can just take whatever system you have, place it into virtual machine, and run it as is. However, historically, this hasn't been, the top level performance possible. So another approach developed, and it was called para-virtualization. This is something that, for instance, Zen does. Basically, instead of the hypervisor scanning the guest memory and replacing the instructions, the hypervisor will instead expose a set of APIs and let guests call the API whenever it wants to do something privileged. The problem with this approach is that you have to modify your guest. And given the rate how the new software is being released, for instance nowadays, it wouldn't be feasible to catch up and do all the modifications. So even though back in the old days the para-virtualization has been used a lot, until the hardware vendors came in. They introduced something called hardware-assisted virtualization, which basically tries to eliminate the need for the para-virtualization. And in case you want to check whether your host is capable of this, you are looking either on VMX CPU flag or SVM CPU flag, depending whether you are running on Intel or AMD architecture. And for some reason, please don't ask me why, this may be not enabled by default on your motherboard. So you need to get your hands dirty and go to BIOS and enable it there. Don't ask me why, I'm no motherboard vendor. This has been such a breakthrough that many hypervisors are built on the top of hardware-assisted virtualization, notably the KVM. Speaking of which, who knows the difference between KVM and QEMU? Come on, raise your hands, don't be shy. Okay, so for those who don't, the KVM is the actual hypervisor doing all the, as I've shown here, full virtualization. And the QEMU is there to emulate the I/O. So it works like this. KVM is a loadable module in your kernel. You will have to enable it if already not done by your distro. And actually QEMU is the one who sets up or call the APIs in the module. And whenever a guest wants to do some I/O, it gets to QEMU, which will then decide where the data should go. How do you enable hardware-assisted virtualization in kernel? In Libert? It's really simple. You just select the correct domain type, which is in this KVM. How does it perform? Well, I've done some testing here on my laptop previously, and as you can see, well, I basically just measured how long does it take for a guest to boot up. So in the KVM case, I was able to get shell in somewhere around 10 seconds, including the 5 seconds group timeout. Yeah, and if I wasn't using the KVM or the hardware-assisted virtualization, just letting the QEMU emulate all the instructions in memory or in software, after 60 seconds, the guest was still booting up, and I couldn't get any shell, so I basically just killed it and stopped counting. Nevertheless, so we can see the hardware-assisted virtualization is performs really good. However, there are still some cases where we want to have the para-virtualization joined in, and it goes like this. So imagine you have some data that you want to send, I don't know, for instance, on a network. You want to download something or upload. Bless you. However, since we are still emulating, still the QEMU is emulating the real hardware, we have to, the QEMU has to emulate it with all drawbacks that it takes. For instance, with all the errors, all the interrupts, and stuff like that. So what if we just instead can take the data from the guest as is, and let just host deal with them without needing for, to do this all emulation miracle. Actually, it's possible. We can use something called virt.io, which is where the para-virtualization kicks in once more. Sorry, and it really boosts your performance. So basically, the virt.io defines a new set of APIs for the guest to use. And since it's a new device model, you have to have drivers in your guest operating system for it to use. However, unless you are running some really ancient system from, I don't know, 40s or something, you can be sure that the drivers are available for you. And the host part drivers, because it's still a new device, are basically built in the hypervisor itself. How do you enable virt.io in Libert? Well, basically, this gets a bit tricky because, for instance, for disks, you have to place them onto the correct bus, whereas, for instance, for interfaces, you have to select the correct model, and same goes for memballoon and stuff. So before doing this, you should really consult the documentation, but it's really easy. You just put the correct value, correct virt.io word into the correct place, either in attribute or element. How does it perform? So I've done measurement yet again on my laptop. So I've had a guest and I've assigned with the network card, and I've assigned multiple models to the network card. So the blue bar is some Realtek device. The red one is an interface, an Intel interface, and the yellow one is virt.io. So we can see with virt.io and one vCPU, I was able to get like 16 gigabits per second, which is, when compared to some Intel with barely 2 gigabytes, it's really boost. However, You can see some slight decrease here in performance, and I suspect that's because my laptop has only 4 cores, well, 2 cores and hyperthreading. So in case where I gave it 4 vCPUs, my processor has to not only process the network data, but also process the vCPUs themselves. So I think that's the reason why. And at this point, I would like to stress one thing that has been that has been demanded for a really long time and has been implemented just quite recently, and it's called virtual GPU, and basically works like this. So you take the OpenGL commands from the guest, pass them through onto your host, and let the host GPU card render them, and basically render them directly into the guest frame buffer. However, this has some limitations because of the process. So for instance, if you want to, emulate an NVIDIA or an Intel GPU, you really have to have the corresponding card in the host as well, because you can hardly emulate NVIDIA and have Intel host GPU card, right? And it also uses some host-side software, which is called virtual renderer. You can check it out online if you want to. So So now we should do some quiz to let me know how you pay attention, and it's a great opportunity for you to win scarves. So the first question. What format does Libert use to store the domain config? Come on. Who said it first? So I can give him scarf. Okay. Stop by after talk and I give you. Okay. How do you enable hardware-assisted virtualization? And in Libert? Nope. Domain type. Stop by, please. And how do you enable virtual? Yeah, you basically set the correct value and to some attributes and elements. Okay, cool. So now I will explain some primitives that are in the Linux kernel that Libert uses when it comes to slightly complicated stuff, and it's C groups. So C groups are a feature of Linux kernel that allows you to either limit or count or basically just isolate some resources that hosts have. And not only that, they can be used for prioritization in between processes as well. So for instance, if you have this greedy application running in your host, you can place it into a block IO C group and just basically limit how much bandwidth it has when trying to access a disk. So the C groups that Libert uses are CPU set. This control group basically tells where you can have a process running on which host CPUs. Block IO described earlier, and memory is basically the same as CPU set but it only limits the memory. So for instance, it tells on which NUMA nodes you can have the process can have some memory. The C groups form some hierarchical tree, but there has been some work in this area lately in the kernel, so maybe this will be obsolete soon. Previously you could place the process anywhere within the tree. With a new approach, you can place them only into lists, but that's we don't need to get too low level here. So how does Libert uses these when trying to performance boost your virtual machine? we use it for pinning. So imagine this big host with many CPUs and many memory nodes or chunks of memory. In this host, some CPUs are more closer to some chunks of memory than the others, and vice versa. So if you have a domain running, which is basically a Linux, traditional Unix Linux process, you want to have the data processing as close to the actual data as possible. So you basically want to tell that my memory should be running here with my virtual CPUs. And of course, even though you are still using virtio, hopefully, your emulator is still doing some work. So we want to have it as close to the domain as possible. So this is, this is slightly complicated to configure in Libert, but it's slightly complicated stuff anyway. So for instance, in this specific case, I've pinned the virtual CPU number 0 and allow it to run on a host CPUs number 1, not 2, and 3 and 4. The same goes for emulator or for memory and stuff. So, how you can boost your storage? Even when it comes to virtualization, you basically have actually 3 layers of caching. So the first one is in the host operating system itself. It's an operating system; it has some cache. All the processes on the system have that. The second is in guest operating system, yet again, and the third one is just in between them in the QEMU. And whenever guest wants to write some data, the data has basically has to go through all of these caches unless configured otherwise. However, it has some advantages and also disadvantages, playing with the QEMU cache. So the QEMU cache can basically be turned off using the cache none, which saves us some time, because whenever data has to pass through these layers, it has to be copied, and it takes some time. However, if for some reason your guest gets disconnected from its storage, the QEMU cache can actually save you from data loss. So if you trust your guest that this scenario won't happen, if you trust your guest that this scenario won't happen, you can turn the QEMU cache off. Otherwise, you should be really cautious about it. One attribute that you may actually see here is the I/O, and it has value of native. The other value it could has is threads. So what does this do? I will refer you to the next talk. Well, actually, the third talk after me, I guess, where this is going to be explained in much more detail, and I think some performance graphs will be shown as well. So, networking. So, back to my previous example, you had some data that you want to pass onto network. You are using virtio. However, how you can enable you want to use something even much faster than that, near bare metal or bare metal. Well, you can basically use a PCI pass-through, which is you take the PCI device from the host, detach it, and place it into your guest and let it use it. However, it has disadvantage in that sense that nobody else beside the guest itself can use it. So before you try this on your own, please make sure that you are connected either to Wi-Fi or via another interface, because you are definitely going to use connectivity. So, well, yet again, another help from hardware vendors was needed, and they have developed something which we call SRIOV, which means that the that the PCI devices are able to create the virtual functions on the fly after the host operating system is booted up, and you can actually pass through only the virtual functions into the guest. So the PCI device is actually, after all, shared with either host or with multiple guests. There's really no miracle here. The bandwidth that such card has, it's basically shared. So don't expect 10 gigabits on a 1 gigabit network. So this is how we configure it in Libert XML. You basically, in this specific example, I'm using a PCI device on this address in the host to be passed through to my guest. And I should mention that these approaches require, yet again, some CPU features. Yeah, not only VTX, but also VTD. Anyway, so there is a couple of things that your host should have when trying to do all of this. So is there some tool that you can use to check whether you have everything you need enabled? Yes, there is. And it's virtual validate. It's a really small binary that lives in our repository, and it will do all the checks that are needed, not only for the QEMU, but for containers as well. And it will print basically some really nice output. And if you failed to set something, it will at least give you a hint where you should, where you should be aiming when trying to enable it. My enumeration of all the possible values that you can set to performance boot your virtual machine or container is not complete and really cannot be complete because we have limited time here. But I would refer you to our documentation and also to our Red Hat documentation where this topic is covered in much more detail. And in case you have any questions, please feel free to ask them on our mailing list. And hopefully you will enjoy my demo that I've prepared. Its aim is to show you the storage boost and computing boost for the graphs I haven't prepared. Just a second. Yeah, I'm here. Okay. And hopefully that's is it visible for you guys? Yeah. So I have prepared two virtual machines, and only. Okay, maybe it's too big. Just a second. Yeah. So in the first difference that we can see is. Yeah, okay, it works. So in the defconf tuned, I really am pinning the vCPUs. I'm enabling, well, basically disabling the cache, cache none. And the other difference that I got here is I'm using virtio when compared to some Realtek device. So let me just, yeah. So for instance, just a second. Yeah. Oh, sorry. Yeah. This is a very small program that I have in both virtual machines. You can see it's basically a dummy program to just do some memory access. So let me see how does it perform. How does it perform here on a not tuned machine? It's gonna take some time, I guess. Meanwhile, I'm gonna run the same program on the tuned machine. Still working, hopefully. No. Yeah, when I tried it at home, it took like 40 seconds, so please bear with me here. Meanwhile, what we can do is to show you how the storage boots up. Super secret password. Nope. So for instance, I can try to write some data on the disk. For instance, one gigabyte, and I'm gonna use this is okay, cool. So in the not pinned virtual machine, it took 43 seconds to complete my little test, and in the tuned, it took only 31 seconds. Cool. Nice. So the write speed has been something about roughly 70 megabytes per second, whereas in this one I was able to get nearly 1 gigabyte per second, which is kind of strange because I don't have so fast SSD. Nevertheless, yeah. So I guess this other example I'm showing is probably spoofed. Never mind. So I think that, yeah.
Do you get a difference on that one with I flag equals full block?
Full block, sure.
I flag equals full block.
And okay, and yeah, so over some slightly over 600 megabytes, and when compared to 150, and okay, so that actually brings me to end of my talk. So the conclusion here is you should enable hardware-assisted virtualization whenever possible. You should prefer VirtIO, and as you can see, the CPU pinning, or actually the pinning itself, makes sense on some small machines as well. But it's easier to explain on huge machines. So if you have any questions, please feel free to ask them now. Yes? So the question was whether the computing directly onto GPUs is supported. As far as I know, we are still trying to work on it. There has been some patches on the upstream list, but frankly, I'm no QEMU developer. I'm a Libert developer, so I maybe have delayed something, maybe have not seen something and stuff. So you should better ask some QEMU developers.
Not actually a question, but I think it's overlooked.
Yeah.
of the host to the deadline, it actually gave a great performance boost, especially on the storage.
Yeah.
The buffers are utilized much better.
Yeah. So the question, or basically point, was that the host disk scheduler has some influence on the disk I/O as well, or disk performance as well. Yes, it has. From all the tests I've made, yes, as you said, the deadline scheduler has performed the best. You know, try and see whatever suits your workload. Yes?
Am I able to put directly the disk?
Yes, you are. Yeah. Well, basically a partition.
No, I meant if I can put the disk as a hardware device into the virtualization. Sure.
Yeah.
Like PCI device.
Yeah.
Question regarding CPU pinning.
Yeah.
Why you use C groups instead of directly accessing the CPU affinity setting from?
Yeah. So the question was why are we using C groups instead of setting the CPU affinity from within the QEMU? The problem is we want to be able to change it afterwards, because sometimes users may have decided that they want to move the vCPUs onto some different CPU set, and it wouldn't be possible for Libert to do so, because at that time the QEMU is itself another process. So we would need to instruct QEMU and kindly ask it to move there, because you cannot really modify the affinity from outside the process. So we just instead rely on C groups. Yeah?
There is a plan to add a functionality of core sharing policy.
Sorry?
Do you plan to add some functionality regarding the core sharing policy? For example, if some machine can share the core or not?
That's already implemented.
Okay.
Yeah. It's in the docs. If you check them, you will find. Okay, so if no more questions, thank you very much. Hi.
Nice talk, man. So,
Thank you.
So, I'm writing a book about